Now I can explain characteristic of absorption. Characteristic of absorption depend upon the specific of the absorbate, nature of the absorbent, reversibility of the process, enthalpy of the absorption, activation energy, layer of absorption, and surface area of absorption. Let us discuss now each of these characteristic effect physical and chemical absorption. In physical absorption, the surface area of the solid or the absorbent has no specific preference for any type of gas molecules or the absorbate because the van der Waals forces that act on the absorbent and the absorbate are universal. However, chemical absorption is highly specific and will occur only when an ionic or covalent bonding is possible between the absorbent and the absorbate. Therefore, we can infer that while physical absorption is not specific in nature, while chemical absorption is highly specific in nature. The amount of gas absorbed by the absorbent also depend on the nature of the gas. All the absorbed different gases are absorbed due to different extent by the same absorbent at the same temperature. For example, at 288 Kelvin, 1 gram of charcoal absorbed 380 cc of sulfur dioxide, 16.2 cc of methane, and only 4.5 cc of hydrogen. The volume of sulfur dioxide, methane, and hydrogen are reported at STP condition. It may be seen from the critical temperature value that higher the critical temperature of the gas, the greater is the extent of desorption. This is because gases that may be easily liquefied at high critical temperature and are more easily absorbed. Can be attributed to the fact that van der Waals forces are strong in range closer to the critical temperature of that gases. The critical temperature of the gas is defined as the temperature above which the gas cannot be liquefied. However high the pressure applied, it can be seen that volume of absorbed gas increase on the critical temperature increase. The critical temperature of sulfur dioxide is 430 Kelvin and hence it is absorbed more on charcoal than methane and hydrogen, which have critical temperature of 190 and 33 Kelvin respectively. In chemical absorption, no correlation is seen between the amount of gas absorbed and critical temperature of the gas, but absorption depends on the chemical nature of the gas. Greater the reactivity of the absorbate, the greater is the amount of absorption. Therefore, we can infer that both physical and chemical absorption depend on the nature of the absorbate. Let us now discuss the reversible nature of the process. Like any other equilibrium, absorption is a process involve the true equilibrium with the absorption one side and desorption on the other side. The two opposite processes include the adsorption of gas molecules on the surface of a solid and desorption of gas molecules from the surface of a solid into the gaseous phase. You know that adsorption is an exothermic process. The equilibrium can be represented as the gas, the absorbate plus solid absorbent is an equilibrium with the gas absorbed on the solid plus heat. On the Le layer principle, it can be seen that when we increase the pressure or decrease the temperature, the equilibrium shift forward, that is absorption increase. Similarly, when we decrease the pressure or increase the temperature, the equilibrium shift backward. That is adsorption decrease. In other words, adsorption take place. For example, 1 gram of charcoal absorb about 10 cc of nitrogen at 273 Kelvin, 20 cc at 244 Kelvin, at 45 cc at 195 Kelvin. It is observed that absorption of nitrogen on charcoal decrease with an increase in the temperature. Thus, we can say that physical absorption is a reversible process due to the presence of weak van der Waals forces of attraction. Next, let us discuss the enthalpy change associated with physical and chemical absorption. In physical absorption, since the van der Waals forces of attraction are weak, the heat evolved or the enthalpy absorption is very little, around 20 to 40 kilojoules per moles. Chemical absorption is an exothermic process. However, in chemical absorption, surface compound form and the forces involved are similar to chemical bond. Thus, a relative high amount of heat is evolved is about 80 to 240 kilojoules per mole. Therefore, we can say that the enthalpy of physical absorption is very low, whereas the enthalpy of chemical absorption is very high. Let us now discuss about the activation energy required for adsorption. Activation energy is the minimum energy required to convert reactant into respective product. Physical adsorption involves only weak van der Waals forces and does not involve the information of surface compounds or any chemical compound. Therefore, it does not require the activation energy. However, as chemical adsorption is information of surface compound, activation energy is required for the formation of chemical bond between absorbent and the absorbate. As gas may be physically absorbed at low temperature but chemically absorbed at high temperature. During the absorption of hydrogen on nickel at low temperature, hydrogen is physically absorbed on nickel. Let us look at the type of molecular layer that are formed during physical and chemical absorption. Layer of gas molecules are absorbed one over another by van der Waals forces in physical absorption. That's why multimolecular layers are formed under high pressure in physical absorption. In chemical absorption, the chemical bond is formed with the molecules that come in direct contact with the surface of absorbent. Hence, only unimolecular layer is formed in chemical absorption. Therefore, multimolecular layers are formed in physical absorption, but only unimolecular layer is formed during chemical absorption. Let us now look at the impact of surface of the absorbent on physical and chemical absorption. Greater the surface area, the greater is the absorption. The charcoal is a good absorbent as it has a porous structure for both physical and chemical absorption. The extent of absorption increase with an increase the surface area of absorbent.